Welcome, dear participants, to our online series Medium Voltage Technology Essentials. My name is Pedro Gomez. I work as a Product Lifecycle Manager for air-insulated medium voltage switchgears, and today I am here with my colleague Miriam Johansson, who works as a Product Lifecycle Manager for gas-insulated switchgears.
I would like to share my personal motivation for creating this training with you. I've been working for Siemens AG since 2017. As a mechanical engineer, I switched from the agricultural and construction equipment industry to medium voltage technology, with which I had hardly any contact at that time. I would have appreciated a compressed basic training when I started. So, I'm more than happy to welcome you to this series.
The Medium Voltage Technology Essentials series comprises 7 informative videos organized into 3 comprehensive blocks. My colleagues and I will guide you through the topics of power supply, components of a medium voltage switchgear, design criteria, construction of a switchgear, our medium voltage portfolio, as well as the current topics of digitalization and sustainability.
Should you have any questions during our series, please do not hesitate to use the Q&A feature located in the upper right corner of this platform. We will ensure that each question receives a detailed response via mail after the event. If you are in full screen mode and cannot see the Q&A field for questions or the chat box, simply press the escape key to exit full screen mode. Now, enjoy your journey on improving your knowledge of medium voltage technology.
And to conclude with the words of the Chinese philosopher Lao Tzu, learning is like rowing against the current. If you stop, you drift back.
Hello everyone, and welcome back to our ongoing series on medium voltage technology essentials. In the previous chapters, I'm sure you have learned about the electricity supply, the structure of the switchgear, the important criteria to consider when you're selecting a switchgear, and of course, about our medium voltage portfolio. And today, I'm going to talk about one of the most important topics that has become very relevant nowadays for medium voltage solutions. That is sustainability approaches to reduce CO2 footprint of your grids. Here's what we'll cover in today's session. First, understanding the key drivers shaping our industry and push for the innovation of the sustainable solutions. And then I explain about examining the latest changes happening in the European regulations and their impact on medium voltage switchgear. After that, I'll talk about how Siemens F-gas-free switchgear technology contributes to a greener energy transition. And last but not least, I will also highlight the importance of the transparent sustainability claims and how a Siemens Ecotech label ensures informed decision-making. With that, let's dive into the first topic, the challenges we face in the modern energy systems. It is no surprise that climate change stands out as one of the most pressing issues we face today. The rise in the natural disasters we witness is closely linked to this phenomenon. Studies show that the global energy systems are among the largest contributors to greenhouse gas emissions. On one hand, the electricity demand is surging due to the urbanization, the rapid expansion of AI technologies, and the growing number of energy-intensive data centers. On the other hand, the aging infrastructure, along with the growth of renewables and the distributed energy resources, is increasing the complexity of these grids. Together, these challenges place added pressure on the grid stability, making any infrastructure that isn't a state-of-the-art going to increasingly vulnerable to evolving loads and grid dynamics. So, our mission is clear. We need to adopt products with lower CO2 emissions, designed with circular economy principles, and equipped with digital features that enhances the grid stability. By modernizing the aging infrastructure with cutting-edge sustainable and digital technologies, we can significantly improve the efficiency of our energy systems. And it's not just the manufacturers like us or customers like you driving these changes. Also, the regulatory boards are also stepping into to address these challenges. A key example here is in Europe, the recent F-gas regulation, which aims to accelerate the transition towards more sustainable solutions. In the next slides, I will give you a very brief insights into the European F-gas regulation. Environmental regulations have always played a key role in shaping our industry, with a growing focus on reducing the greenhouse gas emissions. And one of the earliest global agreements, the Montreal Protocol of 1987, was the landmark in phasing out the ozone depleting substances. Over the time, the focus has expanded from not just from the ozone depletion, but also to reduce the carbon footprint of industrial process. In the European Union, this led to the introduction of F-gas regulation, which was first enacted in 2006, revised in 2014, and most recently updated in March 2024. And this regulation is part of EU's Green Deal, aiming to significantly cut the emissions from the fluorinated gases, which have extremely high global warming potential. The latest version takes even stricter measures, ensuring that the industry transition towards more sustainable alternatives. The updated F-gas regulation is comprehensive, covering several key areas to ensure an effective reduction in emissions. It establishes restrictions on placing F-gas containing products on market, mandates strict control for containment and leak detection, and sets reporting obligations for industries using these gases. For electrical industry, one of the most impactful change is the restriction on F-gas use in medium voltage switchgear. This means the future of the grid infrastructure must move towards sustainable and F-gas free solutions. And the regulation also introduces trade controls, ensuring a phased reduction of F-gas imports and production within the EU. With these measures, the regulation aligns with the broader EU climate goals and reinforcing the transition to a low-carbon economy. And if we look into the timeline, the phase out of the F-gases in the switchgear followed a structured timeline based on the voltage levels. From 1st of January 2026, which is not so long away from now, the use of F6 is in medium voltage, or even the use of F-gases in the medium voltage switchgear for primary and secondary distribution up to 24 kV will be completely prohibited. And from 1st of January 2030, this ban extends to the switchgear for the ratings between 24 kV and 52 kV. And it's important to know that the critical date for the compliance is putting into the operation date, not the purchase or not the delivery date, it's putting into the operation. This means any switchgear installed beyond these deadlines must be fully F-gas free, which accelerates the transition towards the sustainable alternatives. And another important part is the procurement procedure. The regulation also outlines specific procurement guidelines to ensure market readiness for F-gas free switchgear. Starting from 2026, any 24 kV switchgear must be F-gas free unless there is only one manufacturer offering such a solution. In that case, a second procurement round allows the equipment with the global warming potential below 1,000. If no additional offers are received, a third tender round may permit the equipment with GWP, global warming potential above 1,000, which also includes the SF6-based solutions. And this process ensures that the market moves towards sustainable technologies while still allowing for the flexibility in case of supplier constraints. However, operators must notify their national authorities if these exceptions are applied in order to ensure the transparency in the procurement decisions. And in my opinion, the easiest way to comply with these evolving regulations, adopt the proven F-gas free solutions today, like our Blue GIS, eliminating the need for the complex procurement process in the future. And not just this, also beyond the new installations, the regulation also imposes strict rules on maintenance of the existing SF6-based switchgear. From 1st of January 2035, the use of virgin SF6 gas for the maintenance or service will be banned, and only either reclaimed or recycled SF6 should be used. And documentation and reporting requirements will become mandatory to track the SF6 usage, ensuring the full transparency and compliance. And from January 1st, 2025 onwards, any switchgear containing F-gases must be labeled, making it clear which equipment still relies on these greenhouse gases. And I believe these measures highlight a clear message. The future is moving away from the F-gases, and the companies need to start planning for this transition now. And if you look the worldwide, while EU is leading the way with the strict F-gas regulations, the similar movement is happening across the globe. For example, in the United States, states like California, New York, Maine have either already introduced or planning an F-gas regulations. In the Middle East, particularly UAE, is aligning with the global sustainability commitments with regulations under discussion. And of course, Australia and New Zealand are taking action under the Montreal Protocol, preparing the phase out of SF6. And these trends show that F-gas-free switchgear is not just an EU requirement, it is becoming a global standard. And by adapting the sustainable solutions now, the companies can future-proof their infrastructure and stay ahead of the regulatory changes worldwide. And I hope you got some insights in the F-gas regulation now. Now, if we look, and if I summarize the challenges with three key drivers, they are decarbonization, decentralization, and digitalization. While the decarbonization pushes us towards sustainable solutions, decentralization demands more flexibility in energy distribution. And the digitalization enables us to optimize and monitor our grids efficiently. This means, as I mentioned, the future of a power distribution must be more digital and sustainable, with the products that are more environmentally friendly and ready for digitalization and automation. On one side, the digitalization will help the grids become more robust and offer users the ability to monitor their assets and perform a predictive and preventive maintenance. On another side, the sustainability technologies will enable the users to reach their net zero targets by preserving resources and reducing CO2 emissions. And our medium voltage switchgear in both GIS and AIS is also part of our Siemens degree framework, especially in reaching the decarbonization and resource efficiency targets. To address these evolving needs of energy distribution, Siemens has developed BlueGIS, an innovative F-gas-free gas-insulated switchgear. And this technology replaces traditional SF6 insulation with clean air, maintaining the same high performance while significantly reducing the environmental impact. Now, if you see, the BlueGIS is the combination of clean air as an insulating medium, as I just mentioned, vacuum interrupter for the current interruption, and all the features of a traditional gas-insulated switchgear. Now, if we go in detail of each part, the clean air, the insulation medium used in BlueGIS, consists of natural origin gases. It's like nitrogen, oxygen, and carbon dioxide with a global warming potential less than 1. And it contains no F-gases, making it very safe to operate and enables a very easy handling during the lifetime of the switchgear. This insulating medium has no regulatory instructions and no documentation or reporting is required for this gas. Coming to our vacuum technology, and our technology is based on 40 years of rich experience and innovation. It is used in our BlueGIS for circuit breaker applications and also newly for load break switching. They are used in medium voltage GIS today up to 40 kA and up to 3,150 amperes of rated current. And they have a very high mean time to failure and are suitable for all applications in medium voltage networks. And what is more interesting, and in my opinion very impressive, is that the BlueGIS, by eliminating the SF6 gas as an insulating medium, still offers all the proven benefits of a classical GIS, like compactness, high reliability, maintenance-free design, and very low life cycle costs. And today, many of our customers benefit from BlueGIS already by saving almost 2.5 tons of CO2 footprint during its lifetime when compared to a similar classical SF6 GIS. This means the customers can enjoy the benefits of traditional GIS while making a substantial contribution to their sustainability goals. And it's not just our GIS portfolio that is offering the sustainable solutions. Also, our air-insulated switchgear portfolio, like NX Air switchgears, enable our customers to reach their sustainable targets. Its major driver of sustainability starts with eco-design and sustainable manufacturing process, long lifetimes like around 30 years, and of course, no SF6 gas present inside the switchgear. And also, the design enables an easy upgrade and retrofit options, and also with a responsible end-of-life management once the product reaches its end. And if you look into our recent addition of AIS portfolio, it is LPITs, that is, the low-power instrument transformers for NX Air. The LPITs play a key role in enabling the sustainable power systems and exemplify our ongoing efforts to deliver environmentally conscious solutions. By introducing LPITs, the usage of the block-type transformers is eliminated, which saves a very good amount of CO2 footprint by reducing the usage of material and at the same time reducing the ohmic and wiring losses. And due to its wide range of coverage of the primary currents, the LPITs further eases the parameterization of protection relays. Now, very important, I want to talk about the transparency of the sustainability aspects of our switchgear. We see that the transparency in sustainability claims is very critical because today there are many products out there that are claiming to be sustainable, but unfortunately there is very less transparency to such claims. And this is why at Siemens, we have created a label called Siemens Ecotech with a key focus on transparency of the claims that are made. Now, in order to achieve this Siemens Ecotech label, which is not very easy, the product must have at least a Type 2 EPD, which is for Environmental Product Declaration, manufactured in sustainable factories, and product must fulfill at least one of these features in each category during the life cycle of the product. And these categories are split between 3 stages of the product life cycle, very important stages. The sustainable materials represent the manufacturing stage, the optimal use represent the usage stage of the switchgear, and the value recovery and the circularity represents the end-of-life stage. And during these stages, based on the individual features the product fulfill, an Ecotech profile is created. In this slide, you see such an example Ecotech profile for one of our Blue GIS types ADAB24. Here you can see the features this switchgear has fulfilled in order to achieve this label, like, for example, low carbon materials, sustainable packaging, high recycling, and so on are listed here. And all our Blue GIS products have secured this Ecotech label, and we believe this kind of transparency will support and enable our customers to make sustainable choices. Now I will talk a little bit about the environmental product declarations, which are the heart of the transparency that is achieved in the previously discussed Ecotech labels. When you look at the EPDs, today there are 2 types of EPDs. There are Type 2 and Type 3 EPDs. One of the major differences between these 2 types are whether it is verified and certified by a third party or not. And also for Type 2, if you look, it is not mandatory to perform a life cycle assessment. However, all the Siemens Type 2 EPDs today are based on LCA, that is a life cycle assessment. This ensures the credibility of the environmental product declarations, even though they are Type 2. Now, in this slide, you can see how such a document would look like. And this is an example for Type 2 EPD. You will learn about the product in this EPD is made for different life cycle stages and possible scenarios assumed in life cycle analysis, like the tool that is used to perform LCA, and summary of the key performance indicators like global warming potential, resource usage, water usage, human toxicity, and so on. All this information you will find in an EPD document. Also, in one of the pages, you can find a summary of CO2 equivalent values of the switchgear during the 3 stages of the life cycle, like during manufacturing, during operation, and during end of life. Here, you can also see how much of CO2 footprint can be saved when you compare the values of a typical BlueGIS to exactly similar SF6 GIS. And you can see you can save almost 50% of CO2 footprint. Now, you as a customer might be wondering, how can I use this CO2 equivalent savings from the BlueGIS in my CO2 reporting? So, I think, and I believe you all know what is a greenhouse gas protocol. For those who haven't heard it, the Greenhouse Gas Protocol is an initiative for the global standardization of emission of greenhouse gases that corporate entities should measure, quantify, and report their own emission levels. This will help us to able to manage the global emissions. Today, I think more than 9 out of 10 Fortune 500 companies use the GHG protocol in order to report their carbon emissions. And according to this protocol, the emissions are split into 3 scopes. It's a scope 1 emission, scope 2 emission, and the scope 3, either upstream or downstream emissions. I know it's a little complicated, so we have just prepared a nice animation to explain these scopes. So I hope now you got some basic idea how each scope is defined. Now, coming back to our CO2 equivalent page in the EPD, which I've just shown, and based on the video we have just seen, and considering an example of an SF6 GIS, if you look, the manufacturing emissions of this SF6 GIS is reported as scope 3 upstream emissions for our customers. The joule losses related to the operational CO2 emissions are reported depending on the type of the energy source used by our customer. And SF6 leakage CO2 equivalent will fall under scope 1 emissions. And the end of life will come also under scope 3 emissions. Now, if we look the same image with our BlueGIS, with this, our customer drastically will reduce their scope 1 emissions by eliminating SF6 gas. And in addition, if they use the renewable energy to operate the switchgear, then the major contribution of the CO2 emissions of the switchgear during the lifetime can be eliminated. And this is how you and EPD can give you a good overview of the possible emissions of the product and enable our customers to make sustainable choices. In summary, our customers can reduce or achieve zero emissions by using carbon neutral energy sources and by not using SF6 products and by using the products with high recyclable materials. Now, I would like to talk very briefly about our new state-of-the-art IoT solution called Electrification X. I will not go into detail about this topic as there were many other webinars held on this topic. I would just like to show one of the features in this platform that has or that will further enable our customers in terms of sustainable choices. That is the energy management feature. This feature is available as a dashboard with a lot of information that will provide an overview about the energy consumption and the related carbon emissions. And based on the assets, this dashboard will also categorize the emissions into scopes. This means a Blue GIS with this electrification platform, you will have more control over emissions and you get more transparency into your grid. And in my last slide, I would like to talk about our recycling services. Our colleagues from customer service have created a detailed recycling guide for the switchgear, which will ensure very high recyclability of the product at the end of life. Almost all our switchgear has a recyclability rate of above 80%, and for some gas-insulated switchgear, it is almost around 90%. This means we can further preserve the resources and improve the carbon footprint. And with this, we, from the Siemens side, closing the loop of the circular economy. And now I've reached the end of my presentation. I hope you've learned a great share of information about our sustainable approaches for the medium voltage solution. And combined with digital innovations like Electrification X, we are shaping the future of the sustainable power distribution. So if you have any questions, please feel free to contact one of us and we will get back to you. Enjoy your day.